Welcome to section 7.2, apply exponent properties involving quotients. Now, what we're going to try to come up with here is when we have two terms that have the same base, one in the numerator and one in the denominator, what can we come up with as a pattern to help simplify that a little bit? So a to the fifth is the same as a times a times a times a times a, and then a to the third is the same as a times a times a. So when we do it this way, it gets to be a little bit easier to see, oh, we can actually cancel out some of these a's. So if we cancel out one from the bottom with one on the top, and then one on the bottom with one on the top, one on the bottom with one on the top, we come out with an answer of a times a, which is a squared. Well, how can we get to an answer of a squared just looking at where we started from? Well, what we can do is actually just take the top number for our power and subtract that bottom number. So a squared would actually be the same as a to the 5 minus 3 power. And this actually makes some sense because if we are multiplying, when we are multiplying numbers of the same base and we then add their exponents, well, the inverse operation of multiplying is dividing. So it would make sense then that we do the opposite or the inverse operation to the exponents as well. So instead of adding them, we would subtract. So let's go and try some examples of this. So a to the m over a to the n, same base, both have a as their base. So we can then take the power of m minus n. 4 to the 7th over 4 squared would give us a 4 to the 7 minus 2 is 5th power. 8 to the 10th over 8 to the 4th would give us the same base of 8 to the 10 minus 4, which is the 6th power. Negative 3 to the 9th divided by negative 3 to the 3rd, subtract those exponents, 9 minus 3 will give us negative 3 to the 6th. Now this next one will be a little bit trickier because we have to combine the numerator powers first because those are being multiplied. So we would have a 5 to the 4 plus 8 would give us the 12th power over 5 to the 7th on the bottom. 12 minus 7 would then leave us with a 5 to the 5th power. And this next one, remember if you ever just see something by itself hanging out there, that would be the same as doing it as an x over 1. So we can then multiply this through. So 1 times x to the 6th is just x to the 6th. X to the 4th times 1 is just x to the 4th. Now we can go through and subtract our exponents, and 6 minus 4 is 2. Okay, so now we're going to go and work on the power of a quotient property. So if we have a divided by b, and we raise it to the 4th power, that's the same as multiplying a divided by b together 4 times. Well, when you multiply this out then, you would multiply together your numerator, so a times a times a times a is a to the 4th, and b times b times b times b is b to the 4th. So our answer comes out to be a to the 4th over b to the 4th. So this property ends up working the same as when it was all just multiplication. So when you have the power on the outside, you can just distribute it to the inside pieces, assuming it's only multiplication or division on the inside. So let's go and use this a few times. So for this one, we would have a to the m over b to the m. For this next one, we would distribute that 7 into both parts, and we'd come out with a 3 to the 7th on top over 2 to the 7th on the bottom. And we can go and simplify some more things. So we can distribute that 3 in, and we'll get an x to the 3rd on top and a y to the 3rd on the bottom. We can distribute that 2 in on the next one and get a negative 7 squared on top and an x squared on the bottom. Or if we want to multiply that out, that would give you a 49 on top and an x squared on the bottom. For this next one, we will need to distribute that power of 3 into all of the parts. So 1, 2, 3, 4 times. So for a numerator, we will have a 4 to the 3rd times x squared to the third is then going to give us 2 times 3 is a 6. So x to the sixth. On the bottom, we'll have a 5 to the third, and then a y to the third. And for this final problem, it will also be similar to that. We can distribute the 5 into both parts. So you'll have a base of a on top, a power of 2 then to the power of 5 would be 2 times 5 would be 10. So a to the 10th power over b to the 5th. And that's all the more I've got for you for today. So good luck, and let me know if you have any questions.